Hey guys, I'm Max.
And I'm Jake.
And this is our new maths YouTube channel, Crystal Math.
We are going to be talking about a bunch of mathy, nerdy stuff, which is always great. And bear in mind that we're students, obviously, we're not professionals. So if we make a mistake, and we are fairly likely to make a mistake at some point, please just point it out in the comments and we will try to rectify it in our next video. Other than that?
Alright, yeah, that's great. Let's get on with the video.
On with the video.
Alright, Jake, what are you going to be talking about today?
Today, I am going to be talking to you about the prime numbers. I'm pretty sure most of you know about the prime numbers, have heard of the prime numbers, and they go as follows. The first one is 2. It is not 1. I'll be talking about that later. The next one is 3. Then it goes 5. Then it goes 7. Then it goes 11, and so on. And what a prime number is a number that its only two divisors are itself and 1. For example, 2 is only divisible by 2 and 1, 3 is only divisible by 3 and 1, whereas a number like 4 is also divisible by 2, making it not prime. A number that is not prime is called a composite number. I've told you that 1 is not a prime number, and now I'm going to explain why 1 is not a prime number, if that's alright. There is a theory in mathematics called the fundamental theorem of arithmetic, which states that any composite number, or any number even, any integer, can be written as a unique product of primes. So, give me a number.
27.
So that is equal to 3 times 3 times 3. And that is, as you correctly stated, 27. And that is the only way you can write 27 as a unique product of primes. Any other number? Let's take another number. Give me another number.
24.
24. Now 24 is 3 times 2 times 2 times 2. 24, I believe. Yeah, 6, 12, 24. Perfect. And that's the only way you can write 24 as the product of primes. Now, I mentioned before that 1 is not a prime, and that's because if you do count 1 as a prime, not only is 27 3 times 3 times 3, it's also 3 times 3 times 3 times 1. And 3 times 3 times 3 times 1 times 1. And you can do that forever. So suddenly there's an infinite number of products of primes that make every number. The same for this. Of course, you can multiply this by 1 and by 1. And it makes no difference to the result. So people said, alright, let's say that you can make every number as a unique product of primes except for 1. And this happened in so many areas in maths. They just said, alright, screw it, 1 isn't a prime anymore. They kicked it out of the prime group. And that's why. There's no mathematical reason that 1 isn't a prime. It's just we decided it shouldn't be prime anymore. And using the fundamental theorem of arithmetic, we can have a beautiful, elegant proof of how there are infinitely many primes. So let's say we have a list of all of the primes. This is called a proof by contradiction. We're assuming that there's a finite number of primes, and we're going to show that that doesn't quite make sense. So let's say we have a list of the primes. Let's call that P. That is first 2 and 3 and 5 and 7 and 11, all the way up to the nth prime, Pn, which is, we're going to say that that's the highest prime. Oh, that should be a curly bracket. That's the highest prime, we're assuming. Now, let's make another number. How about we multiply all of these together? So, yeah, we multiply all of these together, and then we add 1. And suddenly, this is higher than the product of all of the primes, meaning that it can't be written as a product of primes. Thus proving that this list is incomplete, no matter how full it is. That's the proof there are infinitely many primes. It's beautiful. It can be written down on the back of a napkin. It's so simple. There's one more aspect of primes I'd like to talk to you about. These are the Mersenne primes. So, a Mersenne number is 2 to the power of n minus 1. It's anything that's less than a power of 2 by 1. So, for example, 1 is a Mersenne number, and 3 is a Mersenne number, and 7 is a Mersenne number, because it's less than 2, which is 2 to the 1, 4, which is 2 to the 2, and 8, which is 2 to the 3. So, a Mersenne prime, as you've probably guessed, is a Mersenne number that's also a prime, like this one, not this one. as we've already covered. So these are the Mersenne primes. I think that's about it. That's the basics. Any questions? Anything I missed out?
I think that's pretty good, yeah. We're alright.
Great, fantastic.